Hello, my geometry pain specialists. Today we're going to do lesson 4-6, and it's on page 174, and it's called Equations of Lines. So I'll give you a moment to find that. I'm in print 174. In Braille, it's the first few pages in your volume. On page 174 straight up, it should say Equations of Lines. And typically it starts out with the whole what do you learn information, where it says you'll learn to write and graph equations of lines. And this should be very, very familiar information. This is stuff you've been doing from Algebra 1 days, all right? So a few, down towards the middle of the page in Braille, it starts out with the equation y equals 2x minus 1 is called a linear equation. So that should sound really familiar. Y equals 2x minus 1 is called a linear equation. That just means it makes a line, right? And it says it's a graph that's a straight line, and we can substitute in different values for x in the equation and solve it for the corresponding values of y, and they do that in a table. In Braillers, if you turn the page, it'll have the table, and it'll show where you have x and then 2x minus y, 1, and then y, and then the x and y points, and it plugs in the values 0, 1, 2, and 3, and then it shows the work. 2 times 0 minus 1 equals negative 1. That would be your y value. 2 times 1 minus 1 equals 1. 2 times 2 minus 1 equals 3, and 2 times 3 minus 1 equals 5. And then it puts them in ordered pairs on all the way to the right. Print users, you have a table on the top right. So if x is 0, y is negative 1. If x is 1, y is 1. If x is 2, y is 3. If x is 3, y is 5. And then it says then we can then graph the ordered pairs. So the next Braille page is a graph of the ordered pairs that you just solved for doing that table. You have your x and y axis, and they plotted each one of the points, the 0, negative 1, the 1, 1, the 2, 3, and the 3, 5. And then they drew a line connecting all those points to show that that's the equation of the line y equals 2x minus 1. So if you take a look at the graph, you're going to find a diagonal line running from about 7 o'clock to 1 o'clock, and all the points are going to be plotted on that, and to the right of each point they're going to label the points A, B, C, and D, and then give the ordered pair. Point A is 0, negative 1, 0, negative 1. Point B is 1, 1. Point C is 2, 3. And point D is 3, 5. And then they draw a line in between, and then to the left of the line they put y equals 2x minus 1, because that's the equation of the line. And you did this back in Algebra 1 days again and again and again. I'm sure your Algebra 1 teacher had you graph linear equations. We have a slope on this line. You could take any of these 2 points based upon what you learned in the previous lesson, and you could find the difference of their y values and the difference of their x values and figure out the slope. So if we took point A and B and we found the difference in their y values, negative 1 minus 1 is negative 2, 0 minus 1 is negative 1, negative 2 over negative 1 is actually positive 2. The slope is 2 over 1, up 2 over 1. If you started at a point You went up 2 and over 1, you'd get to the next point. From point B, if you went up 2 and over 1 to the right, you'd get to C. From point C, if you went up 2 and over 1, you'd get to point D. So you would have the slope of 2, all right? Notice that your coefficient of your x on your y equals 2x minus 1 is 2. So that brings us to a very important form that you learned back in Algebra 1 days. If you turn the Braille page, you're going to get to information about that particular form. And recall that find where it says kind of get your way down the middle of the page. It should say, almost all the way to the bottom, it should say y equals 2x minus 1. And there's going to be some little arrows interpreting that value. And just below, it's pointing at the number 2, and it's saying that that is the slope. The coefficient of your x is the slope. And the minus 1 is your y-intercept. And this is called slope-intercept form. And I'm sure all of you are probably going, yeah, y equals mx plus b, right? Y equals mx plus b, where m, the coefficient of x, is your slope, and b is your y-intercept. Where does it intersect the y-axis? Where would you start a point? And so the equation y equals mx plus b is slope-intercept form. Super important equation and form to be able to memorize and use, because then if you just know, if you just get it into slope-intercept form, you don't need to make a table. You could graph just based upon this slope-intercept form of y equals 2x minus 1. We would know our y-intercept is negative 1. It's not plus 1, it's minus a 1, so it's negative 1. So we would start on our graph at the negative 1 position on the y-axis. We'd put a point there. And then from that point, we do our slope. And we know our slope is 2, which is a whole number. So we actually would say that's 2 over 1, rise over run, 2 over 1. So from that point on the y-axis at negative 1, we would go up 2 spaces and over 1 to the right and make another point. And then we could connect those 2 points, and we would have our equation of our line without having to do a table and a whole bunch of manipulation of this equation to figure out our y values, which is very convenient. So the next Braille page, there's a page break, and it's 175. Print users, we're going to move to 175, and we're going to discuss this example so that we can practice using our y-intercept form to figure out the slope and the y-intercept. We're going to use our slope-intercept form, our y equals mx plus b, to figure out our slope and our y-intercept. So the first example, number 1, our equation is y equals 1/2 x plus 5. This is a very simple, straightforward, already into slope-intercept form for us. We don't have to solve for y. So all you have to do is extract out the information you need. The slope is the m value, the number next to the x. Slope m equals 1 over 2. The y-intercept is your b value, the constant, the 5. So the y-intercept is at positive 5. So what this means is that on a graph, we would start at positive 5 on our x-axis, or our y-axis. Doggone it, I'm bumbling my words. Start at the 5 on the y-axis, and our slope is 1 over 2, isn't it? 1/2. So that means we go up 1 and over 2. Up 1 and over 2. Up 1 and over 2. And then we connect the dots. All right? They didn't show you the graph on here, but I'm just kind of doing it on my whiteboard for those that have some vision that can see it. All right, the next equation, example number 2 is y equals 3. This is in slope-intercept form, believe it or not. You might say, well, where's the mx? You could rewrite this y equals 0x plus 3, because there is an x in this. It's just nothing. So you could rewrite it 0x plus 3. So that means your slope is 0. And you learned and have reviewed in the last section and learned in Algebra 1 days that when you have 0 slope, that's just a flat line, isn't it? It's a horizontal line. And then our y-intercept is 3. So what that means on a graph is that on the y-axis, you make a point at 3, and because your slope is 0, it's a horizontal line, it's a flat line, a parallel line to your x-axis. You just draw a straight line east to west through the y value of 3, and the y value of 3 into infinity on the left, and y value of 3 into the infinity on the right. There's no x values here. It's a flat line, right? So when you have an equation of a line where it's y equals just a number, what that means is just plot the number at the y value. So we're going to plot 3, and we're going to draw a line, because actually it's y equals 0x plus 3. The slope is 0. Okay. Example number 3. Example number 3 says x equals -2. So you look at this and you go, oh, wait a minute. Can't put this in slope-intercept form because there's no y. Y doesn't exist. So this means that it's just x exists. And if you were to graph this, that would mean you graph a point at x equals -2. So we put a point at 2. There's no y value, so it means y is always 0. So this is a vertical line. So the slope is undefined. It's a vertical line. I struggle with the undefined because we know that it's a vertical line. So that is a bit of a definition. But describe it as slope, we can't. It's just a vertical line. It doesn't slope one way or the other. It's not flat. So it's a vertical line. The x value is at -2. So 2 to the left of your origin, and then you just draw a line from north to south, 6 to 12 o'clock, 12 to 6 o'clock, straight up and down line. So when you come across an equation of a line where it just has an x value, it's a vertical line. Plot it, draw a line. All right, and slope is undefined. If they ask you what the slope is, you say slope is undefined. Okay, the next equation, it's at the very bottom of the Braille page, and then you have to turn the Braille page for all of the explanation. So it's 2x minus 3y equals 18. Very bottom of the Braille page, 2x minus 3y equals 18. If you turn the page, it takes us through the process. Now we notice from this equation of a line that it's not in slope-intercept form. It's in ax plus by equals c form. It's standard form. That's not super useful for what we want to do with graphing. It could be useful for finding other things later, but right now we want it to be in slope-intercept form. So we have to manipulate this equation using our algebra tools and our algebra toolbox with our addition and subtraction properties of equality and our multiplication and division properties of equality and simplifying to get this into y equals mx plus b form. And you did a ton of this, or should have done a ton of this in Algebra 1. You got to practice this here. So we have to solve for y. We have to isolate y. So we got to get rid of what's happening around y. So the 2x, it's a positive 2x. They show in the next step. You're going to subtract 2x from each side. So 2x minus 3y minus 2x equals 18 minus 2x. Oops, I wrote a y. 2x. So we're canceling the positive 2x by subtracting 2x on the left. If we subtract 2x on the left, we got to subtract 2x on the right, keep our equation balanced. So the next step, they just show it simplifying. Now you have -3y, because the 2x's cancel, equals 18 minus 2x. Now, negative 3 is hanging out next to y, and it's multiplying it. So to cancel, to undo the negative 3 multiplying y, we have to divide by negative 3 on both sides of the equation. So the entire quantity of 18 minus 2x has to be divided by negative 3. Then they simplify. Negative 3y divided by negative 3, that cancels and just becomes a y. And then this is where you have to be super careful. You have to remember that if you're dividing the entire quantity of 18 minus 2x by a negative 3, the negative 3 distributes itself to the 18 and it distributes itself to the negative 2x. So 18 divided by negative 3 is negative 6. And minus 2x, or negative 2x divided by negative 3 is actually plus 2 over 3x, 2/3 x. It becomes a positive because we have a negative 2x and a negative 3. So we rewrite, they also rewrote y equals negative 6 plus 2/3 x, because the negative 3 had to apply itself to both terms. Now this is still not y equals mx plus b form. We need to rewrite it. So we need to flip our 2/3 to the front, our 2/3 x in the front, so 2/3 x, and then plus b would be a minus 6, or you could say plus negative 6, or you could just write minus 6. Don't forget that's a negative 6. So now we have it in slope-intercept form. Y equals 2/3 x minus 6. So in this form, now we can identify the slope and the y-intercept. The slope is 2 over 3, or rise over run, up 2 and over 3 to the right, and the y-intercept is negative 6. So what this means is we start at negative 6 on the y-axis, and from that point we rise up 2 and go over to the right 3, because our slope is 2 over 3. And we do that, and then we connect the points, and we create our graph. Okay? All right. The next example, they take us through a lot of examples that covers everything. So find, well actually they do a your turn first. So there's a your turn in the midst of this. So let's do that. The first one is little letter A, and it says y equals negative x plus 8. Identify the slope and identify the y-intercept. So first we go, yay, it's already in slope-intercept form. Everybody say yay. All right. What is our m value? This is a little trickery. Sometimes students get tripped up on this. You got to notice that it says negative x, which actually means negative 1x, right? So your slope is negative 1, or negative 1 over 1. You're going to go down 1 and over 1 to the right, down 1 and over 1 to the right. And your y-intercept is pretty basic. It's just 8. So this means you start out on the x-axis. Oops, I wrote a graph that looks a little crazy here. Start out on the y-axis at 8, and then go down 1, over 1 to the right, down 1, over 1 to the right, and then connect the dots. And you have your line y equals negative x plus 8. It's negative slope. Should pitch that way. Pitch to the left. All right. Next practice. Little letter B is x plus 4y equals 24. So you write that out, and you take a look at it, and you go, oh, rats. It's not in slope-intercept form. But we're going to use our algebra tools, and we're going to manipulate the equation to get it into slope-intercept form, to solve it for y. So first we have an x, a positive x, that we need to get rid of on the left side. So we're going to subtract x from both sides, and we're going to get 4y equals 24 minus x. Then the 4 times y, we have to divide by 4 to undo that. So we're going to divide by 4 on both sides. And y equals 24 divided by 4 is 6. And then minus x divided by 4. Remember, there's a 1 sitting next to your x. So that would be 1 divided by 4, or minus 1/4 x. That trips people up too. That minus x, they want to just say, oh, it's 4x. It's 4 divided into x. So remember, there's a 1 sitting next to the x, so it's actually 1/4, or 1 divided by 4. So it would be minus 1/4 x. And then again, you notice this is not totally in mx plus b form. You need to flip your x forward. So we have y equals negative 1/4 x plus 6. Now that's in y equals mx plus b form. So your m value, your slope is negative 1/4, and your y-intercept is 6. Right? So couple little trickery things to remember here. First, it's not in the form. You got to start manipulating it to be in the form. And then notice that when you divide by 4, remember that minus x has a 1 next to it. So it's going to be 1/4, 1/4 x, 1 divided by 4. Okay? All right, little letter c, we like this one. Little letter c is just y equals negative 1. Well, once you find that, once you see that, you know, oh, I'm just going to mark a point on my y-axis at negative 1, and then I'm going to draw a line straight across, horizontal to the x, or parallel to the x-axis. It's a horizontal line because I know that really this is y equals 0x minus 1. I have no slope. I have 0 slope. It's a flat line. So when you see those, you're like, yay, that's easy. Same with little letter d. X equals 10. Aha, no y in this. So we go, oh, this just means I have a graph where the x value is at 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I have a vertical line going up and down parallel to my y-axis because my slope doesn't exist. It's undefined. So I just have a point at x equals 10, and I draw a line up and down. All right? So we like those two. Whenever it's in slope-intercept form, it's nice and tidy for us. When it's just y equals something, we know it's a horizontal line. When it's just x equals something, we know it's a vertical line. Okay? Now, the next example is really cool because it actually shows you a graph of what's happening. I've been talking about that, but it takes us through it. And so we have example number 5, and it's on the next Braille page 175B, example 5, and it says graph 2x plus y equals 3 using the slope and y-intercept. So we're going to get it in slope-intercept form. So we notice this equation is 2x plus y equals 3, so they walk us through what you have to do. You have to rewrite it in slope-intercept form. Well, we want to get y by itself. This isn't too hard on this one. All we got to do is get rid of this 2x. So we got positive 2x. We want to subtract 2x from both sides. So we have 2x minus 2x plus y equals 3 minus 2x on the right. The 2x's cancel. 2x and minus 2x cancel. We end up with y equals negative 2x plus 3 on the right. Okay. You might have 3 minus 2x, and then remember you got to flip it and put your negative 2x first plus 3. So you know your slope is a negative 2, and you're going to put that over a 1. So you know it's negative 2 over 1. You know your rise is negative 2 and your run is 1. And then your y-intercept is a 3. Now they graph it in the next tactile on page 175C, and to the right at the bottom of page 175, they show the graph and how it's done. It's not too bad. You find your x and y axis, and notice that because your y-intercept is at 3, they went up 3 from the origin and put a point, and they labeled it 0, 3, right? And then from that point, they did the slope, and the slope is negative 2 over 1. So they went down 2 from the point, your y-intercept, 1, 2, and then over 1 to the right, because it's a positive 1 on the x value. And they put another point. And they showed it with little brackets. They showed it going down 2 and then over 1. They kind of labeled that. They said, okay, we went down 2, and then we went over 1. And then they drew a line in between those 2 points, extending up through the top through about the 11 o'clock position and put an arrowhead, and then back down through about the 5 o'clock position they put an arrowhead. And that's the equation of the line 2x plus y equals 3, or in slope-intercept form, y equals negative 2x plus 3. The slope is negative 2 over 1, and the y-intercept is 3. Now, what I want you to do is learn how to describe these to someone where they would have to draw it for you. Because in college, you might not have ways to graph, but you might have a scribe, and you might be able to say, or you might be able to tell the teacher, okay, what I'd like you to do is put a point at the y-intercept, which means put a point on the y-axis at positive 3. And then from that positive 3, I would like you to go down 2 units on the y-axis, and then over 1 to the right, parallel to the x-axis, and make another point at 1, 1. And then I would like you to connect those 2 points with a line. So I want you to do that in your homework and on the next exam. You don't have to make a graph, but what you have to do is tell me, if I was your scribe, how I would make the graph for you. Think about your orientation and mobility exercises. You have to be very specific about what you would tell me to do. Just don't say, well, put a point at 3. Okay, there's a point at 3 all over this graph, right? You have to be specific and say, on the y-axis, please mark a point at positive 3. And maybe your scribe will go, well, where's that? And then you have to say, from the origin, from where the y and the x cross, count up 3 places. You might even have to get more specific, because you might have a scribe that's an English major that has no idea what you're talking about because they can't stand math and they stop taking it. And then from that point, you would tell them, okay, now go down 2 on the y-axis and then go 1 to the right, parallel with your x-axis, and make another point. And then take a straight edge and connect those 2 dots. So that's what they did in this graph. That's what you'll have to do when you start. Now they give us a your turn. If you turn the page, it says your turn again. It says graph, oops, use my wrong pen on that. Graph negative x plus 3y equals 9. So negative x plus 3y equals 9. Not in y, it's not in y, slope-intercept form. So we need to add x to both sides because we want to undo that negative x on the left. So we have negative x plus 3y equals 9 plus x. So we have 3y equals 9 plus x. We're going to divide by 3 on both sides. So we can cancel out that 3 multiplying the y. So we have y equals on the left, and then you have to distribute that division of 3 to the entire quantity of 9 plus x. So you have to do the first term 9. 9 divided by 3 is 3. And then the second term is x. What is sitting next to that x? A 1. 1 divided by 3 is 1/3 x, right? Don't do it in a decimal form. That's just messy. Just write 1/3 x. We like that. And then you rewrite it in y equals mx plus b form, so that would be y equals 1/3 x plus 3. Now we have a nice tidy slope-intercept form, and we're able to graph based upon this y equals 1/3 x plus 3. Our slope is 1 over 3, right? And our y-intercept is 3. So if we were to describe this, we would tell the scribe, all right, please put a point on the y-axis at positive 3, 3 up from the origin. Now from that origin, please go up 1 and over right 3 and make another point. And then those 2 points need to be connected using a straight edge and extended both up and down to make a line with arrowheads on each end, right? So that's what I want you to do. I want you to describe your answers when you do your work. How would you graph it? How would you tell a scribe how to graph this? Okay? Excuse me. And that's all we're going to do as far as lecture is for 4-6. Tomorrow, when we're live and in person and starting our review for Chapter 4, we'll discuss how to take a line and make another equation to that line that's either parallel or perpendicular. But I want to do that with you in person. So what I'd like you to do for extra practice today, oops, used the wrong pen again. You're laughing, aren't you? Is I would like you to do page 177, and it's going to start in Braille, I believe. Turn a few pages. It's a page break, page 177, but actually where you need to start is on 177C. 177, or excuse me, 177B in Braille. 177B in Braille. In print, it's 177 in the middle of the page. I would like you for classwork today, and we're going to go over these tomorrow at the beginning of class. I would like you to do number 3 through 9. Number 3 through 9. You have to identify, you have to get them into slope-intercept form. If they're not, you have to identify the slope and the y-intercept, and you have to describe what the graph would look like on each one of these. So just like we did with the previous problem, you work your way through it and show your work, identify the m value, the slope, identify the y-intercept value, and then tell the scribe, tell me in words, how would you graph this? Where would you put your points? All right. I want good writing on this, good directions. I want to be able to just, we go through these and I'd know exactly where that line, the equation of the line would be on the graph. All right. So that's your task today, is to do number 3 through 9. You can help each other, but your work all has to be well done and you have to agree upon it. And if you don't, you need to help each other figure out why it is so. All right. And we'll go over these tomorrow. Have a good day.